All right, today we're going to talk about inverse trig functions. We are going to start, we started yesterday with sine and cosine inverse. Today we're going to talk about secant and cosecant. So let's start with the bell work. So the bell work starts off with, well, sine inverse of -1/2. Well, what they're asking for is basically where does sine equal 1/2 on our unit circle. However, for sine inverse, we have to get rid of quadrants 3 and 2. Which means we're just looking at these two quadrants. Well, if you locate -1/2, that's right there. Well, it looks like it's at 11 pi over 6 if you're looking at unit circle. However, in order for sine inverse to work, we have to use the negative pi over 6 version of that. So it has to be negative pi over 6. It can't be 11 pi over 6. All right, our cosine of 1/2, we're locating on our unit circle where cosine equals 1/2. Well, cosine equals 1/2 at pi over 3. So the answer to that one is pi over 3. All right, let's go right into this cosecant stuff. So cosecant, the inverse of cosecant, we're going to start off with what does cosecant mean in terms of sine. Well, the first time we saw cosecant this year was in this example here. What basically happens here is, let's focus on the cosine real quick, or the cosecant. Well, if I say find the cosecant of pi over 6, what you're actually going to do is you're going to find the sine of pi over 6 first. You're going to see what that value equals. You're going to take the reciprocal, and that's going to give you your cosecant value. So in other words, the cosecant of pi over 6 is going to equal the reciprocal of sine of pi over 6. So where sine of pi over 6 spits out 1/2, cosecant of pi over 6 is going to spit out 2 over 1, which led us to an equation that looks something like this. We said when we're given cosecant of an angle, we're just going to say, okay, find sine and find the reciprocal of that, which looks like 1 over sine of that same angle. In other words, find that sine of it and flip that value. That's what happened up here. We said, well, the sine of pi over 6 is 1/2. Flip it, and you now have your cosecant value. Well, what I want to point out is what's actually being, the reciprocal being taken of is the 1 over 2 and the 2 over 1. And why that's important is because when we're doing inverses, we're flipping what we're looking for. In other words, the sine inverse of 1/2 should spit back out that pi over 6. And that cosecant inverse of 2 over 1 should spit back out that pi over 6. So that leads us to what I have written over here. That the cosecant inverse of 2, which is 2 over 1, so that's the same 2 over 1 that's there, is equal to the sine inverse of 1/2, because both of those spit out the same pi over 6 when you're going backwards. Which we can then write in a formula that looks like this. We can say, well, you know what, if I have cosecant inverse of some value, note it's not an angle. Over here we're talking about an angle. Here we're talking about some value that we're given. Like this, we have 2 and 1/2. Those aren't angles. So if we're giving cosecant of some value, and that's not on our unit circle, we're going to convert it to sine. Well, no, we're going to take the reciprocal inside the parentheses. We're going to take the reciprocal inside the parentheses. So I'm going to put a little note. You know what? If you're doing the inverse, the reciprocal is going to be taken inside. So inverse inside. If we look over here, we took the reciprocal on the outside. The reciprocal happens at the end. For inverses, the reciprocal is the first thing that's going to happen. We'll get to some examples of that. First, we're going to talk about the graph of cosecant and what quadrants it lives in. So let's start off by drawing a basic sine graph, because that gets us to our cosecant. So basic sine graph starts at 0, 0, goes up 1, comes back to our sinusoidal axis, goes down to -1, goes back to 0. I'm also going to plot one point at negative pi over 2, -1. I should also label my y-axes. There we go. This is a basic sine graph. Well, basic sine graph gets us our basic cosecant graph. All we have to do is put vertical asymptotes at where it hits the sinusoidal axis. And then we flip the bumps. All right, so that goes up like that. This one will go down like that. And finally, at that negative pi over 2, that one's also going to go down. Well, the nice thing about cosecant is that we're going to restrict to the exact same quadrants we did for sine. So for sine, we did negative pi over 2 to pi over 2. We're going to do the same thing here. We're going to restrict it to negative pi over 2 all the way to pi over 2. And that is going to be our invertible function. It passes the vertical and horizontal line test in that green box, which means that our cosecant is going to be in quadrants 1 and 4, just like sine was in 1 and 4. All right, let's go ahead and create the graph of our cosecant function, our cosecant inverse function, I should say. Well, to create a graph of an inverse, you just have to flip your x and y values. So you can kind of see me highlighting some points. I'm going to highlight this point, which is pi over 2, comma 1. If you flip those values, we will have 1 pi over 2 right here. Then moving to the left, I'm going to notice that we have a vertical asymptote at x equals 0. It's a vertical asymptote along our y-axis. So when you take the reciprocal of that, anything that's going vertically is now going to go horizontally, and rather than be in the y-axis, we're going to go across the x-axis. So that is our horizontal asymptote. And finally, our last point here is negative pi over 2, comma, negative 1. I'll flip those. We'll have negative 1, negative pi over 2. All right. Let me go ahead and write that down. Actually, negative 1, negative pi over 2. All right. Both of these are going to be attracted to that horizontal asymptote. And so our graph of our cosecant inverse function is going to look a lot like this. And that combined. That's our cosecant inverse of just a basic x. All right, let's note down here, cosecant inverse and arc cosecant are the exact same thing, and we are restricted to quadrants 1 and 4. All right, let's do some examples. So our first example says cosecant inverse of square root of 2. Now, like I said, cosecant values aren't on our unit circle, nor do I want to just memorize them all. That's too much, because otherwise you have to put 6 things at each 30 degree, 45 degree. That's too much to remember and to get straight. So instead of worrying about cosecant, I'm going to convert it to sine. So I'm going to convert it to sine inverse. Well, the way to do sine inverse is you're going to take the reciprocal inside. Inverse, inside. Inverse, inside. We're also going to note that we can't have a square root in the denominator. So we're going to go ahead and multiply the top and bottom by square root of 2. And so rather than cosecant inverse of square root of 2, I'm actually looking for the sine inverse of square root of 2 over 2. Well, that's going to be our second tick mark of our sine, and that's going to equal pi over 4. Our answer is going to be pi over 4. Or our next one is the arc cosecant of 2. Once again, cosecant isn't on our unit circle, so rather than arc secant, we're going to create sine inverse. In order to do that, we need to do the reciprocal on the inside. So 2 over 1 becomes 1 over 2. Well, where is sine equal to 1/2? Well, sine is equal to 1/2 at our first tick mark, or pi over 6. All right, cosecant of 3 pi over 6. The first thing I realize is, well, 3 pi over 6 isn't even simplified. So I'm looking for the cosecant of pi over 2. The next thing I'm going to recognize is the fact that there is no inverse. We're actually looking for the cosecant of pi over 2. Well, if we're following along with the inverse and we make a big mistake, we're going to realize that, don't write this down, but if you'd accidentally do the reciprocal inside, you'd be looking for the angle 2 over pi. That angle does not exist. Well, you probably would have changed this to sine as well. So you probably would have been thinking, if you're following this, that is the sine of do the reciprocal inside. But we aren't doing inverses, and it doesn't make sense to have a 2 over pi. That's not an angle that we know of. Since there is no inverse symbol, instead we're going to do the reciprocal on the outside. So that's going to be 1 over sine of pi over 2, which tells us find the sine of pi over 2 and flip that value. Well, the sine of pi over 2 is 1, so we're talking about 1 over 1, which is just 1. So no inverse symbol, we're going to do it like this. We're going to do it on the outside. It'll be the last thing we do. If we look up right above it, inverse told me to do it inside. All right, next one is an inverse, so we're going to do the reciprocal inside. So we're going to have sine inverse of, well, the reciprocal of 1 over 1 is still 1 over 1. So we're looking for the sine inverse of 1. Well, where does sine equal 1? Well, that's going to be all the way up at pi over 2, which we just did in the previous c value. All right, so that's how you deal with cosecant inverse and how you deal with just regular old cosecant, just as a little review for that. All right, let's go ahead and move on to the inverse of the secant function. Well, if you understood the cosecant, you'll understand secant. The only difference is we're going to talk about cosine. So if you know the cosine of pi over 4 equals square root of 2 over 2, that means the secant of pi over 4 will be that reciprocal, 2 over square root of 2. And remember, inverses go the opposite direction. So that means the secant inverse of 2 over square root of 3 better spit back out pi over 4. And the inverse, or the cosine inverse of square root of 2 over 2 is going to spit back out pi over 4 as well. So that's going to give me that secant inverse of 2 over square root of 2 is the exact same thing as cosine inverse of square root of 2 over 2. So you do the reciprocal inside, and either way that's going to spit out pi over 4. That's going to lead us to the equation that, hey, if I'm given a secant inverse of some value, we're going to say, well, secant's not on my unit circle. I'm going to talk about cosine inverse. And I just have to take the reciprocal inside, and the two things are equal to each other. All right, that's what we're doing if we're doing inverses. Let's go ahead and graph it and go through some examples. So cosine is our key to graphing secant. So we're going to graph a normal cosine curve. It's going to look something like this. I'm going to go ahead and label my y-axis as 1 and negative 1. To graph secant, we do have to put vertical asymptotes at our sinusoidal axis, where our graph intersects our sinusoidal axis. And then we're going to flip the bumps. The good thing about secant, just like with cosecant, is it's going to replicate what we did with cosine inverse. And that is we're going to restrict our quadrants from 0 to pi. So that means our secant lives in quadrants 1 and 2. So when I'm looking for secant inverse, we're only going to look at quadrants 1 and 2. All right, the graph of this. Once again, we're going to go ahead and plot key points and flip their values. So that point way to the left is actually the point 0, 1. Flip 0 and 1, and you're going to get 1, 0, which is right here. If we look at, we have a vertical asymptote at pi over 2. So its reciprocal is going to have a horizontal at pi over 2. Then we come down here and we go, well, that point is pi, comma, negative 1. Flip those values in, negative 1, pi. We're going to have a point way up here. All right, then these are going to be attracted to the line, and they're going to look something like that. All right, so that is our secant inverse graph. All right, let us continue on. All right, the inverse of secant is noted as secant inverse or arc secant, and is restricted to quadrants 1 or 2, which we just said. All right, when we're doing secant inverse, it's not on our unit circle, so we do need to rewrite it as cosine inverse. In order to write it as cosine inverse, we must take the reciprocal inside. So rather than 2 over 1, we're going to have 1 over 2. Well, cosine inverse is asking where is cosine equal to negative 1/2. Well, if we look at our unit circle, it equals negative 1/2 right here, which is that 2 pi over 3. So we're going to go ahead and put 2 pi over 3 for that one. Our next one is arc secant of 2. Once again, we have to put it as cosine inverse. We do the reciprocal, which would be 1 over 2. Well, the cosine inverse of 1 over 2 is just pi over 3. At pi over 3, cosine equals 1/2. All right, let's do a quick recap. Quick recap is, if I was given the test, so next Tuesday we have a test. So when I'm handed out the test, at the very top, I'm probably going to write, well, cosecant sine to remind myself that the inverse of sine is in quadrants 1 and 4, and the inverse of cosine is in quadrants 1 and 2. Well, now we can add to that. We can say, well, if cosine inverse is in quadrants 1 or 2, its reciprocal, which is secant, will also be in those quadrants. And for sine, we go to cosecant, will also be in quadrants 1 and 4 along with sine. That way I know when I get to that part of the test, we can get that part correct. All right, the other thing I want to point out is our two different versions of secant. So if I'm just given secant of an angle, to convert it to sine, we have to do 1 over sine of that angle. Notice on the outside, you're going to find the sine value, and you're going to flip it. I'm sorry, we should be cosine. So we're going to do the cosine of that. Well, if I give you the secant inverse of some number, you have to do the reciprocal inside. So to convert it to cosine inverse, you're going to do the reciprocal inside. That's a big difference, and you have to remember both of these. You have to keep it straight on the test on Tuesday. All right, the same thing works for cosecant and sine. If I have cosecant of some angle, we're going to have 1 over sine of that angle. If I give you cosecant inverse of x, that's going to equal, well, we're going to do the inverse inside. So the sine inverse 1 over x. My hint to you, if you find yourself flipping a angle, so say you have pi over 6 and all of a sudden you flip it as 6 over pi. You made a mistake because 6 over pi is not on your unit circle. Whatever you're working with, it has to end up on the unit circle. It has to be a value you understand. If it's not, go back and try another method. So once again, inverse inside. And below are all the graphs that we've done so far. All right, good luck on the homework.